Rhino's dropping bombs.
Hello and welcome to Defend the Rhino. This is a special event today for schools involved in the Data Education in Schools project. I'm Craig, I'm a computer scientist, I'm a gadget geek, and I'm interested in all things tech. And I love everything to do with data and computers. And you're about to get hands-on and learn data science skills in this interactive activity. Now, data science is the set of skills that people need to be able to ask questions, collect, analyse, interpret and communicate about data. And we need more people to know how computers can use data and how to use data to help humans make better decisions. With me today, it's Digital Park Ranger David. Hi, David.
Thanks, Craig. Hello, I'm David. I love all things digital, but I'm especially interested in ways that we can use technology to help people and to help animals as well. So that's why today we're here in our National Park Operations Centre near South Africa, and we have a huge amount of data to deal with today. So data is information. That means things that we know. So things like facts, figures, measurements, things that we can count. And data science is about collecting data, understanding it, and using that data to make decisions. So today we're joined by a network of data scientists. That's you. And you're joining us from all over Scotland and further afield. So let's do some shout outs to people taking part today. Who's joining us, Craig?
All right, so I can see some of the groups who signed up today. So when you hear us say your class's name, I want you to shout out and give us a cheer nice and loud. Make sure that David and I can hear you in our digital dens. So David, who we've got joining us today. So hello to Duns Primary. Hello to you. Thanks for taking part today. David, there are 4 classes taking part.
Wow. Hello, Duns.
Hello to Pathhead Primary. Thank you for taking part today. And Cramond Primary. Thank you for taking part. Got a few more people, David, as well.
Yeah. No Park Primary. Thank you for joining us. It's great to have you with us. And East Calder Primary. 3 classes from East Calder. So thanks for joining us, guys.
It's brilliant. David, we're going to have a good gang of data scientists joining us today.
Absolutely. And we'll be doing some more shout outs later on as well. So we're so happy to have you joining us. Craig, what is it that we're going to be doing today?
The charity Save the Rhino says that South Africa has been the country hardest hit by illegal poaching. By 2017, 1,000 rhinos were being killed every year by poachers. Our park ranger, Bokamozo, has received a message that poachers have been seen nearby. We think they're preparing to attack a crash of rhinos, and we think they'll attack soon, so you need to work together. Today, you'll be our data science team and help us stop the gang of rhino poachers. First, you'll collect data from security cameras across the national park. Then you'll analyse that data to look for patterns and suspicious activity. Finally, you'll visualise that data and figure out where the poachers are so we can stop them in time.
So, are you ready to get started? Let's watch a video and learn more about our mission today.
Well, let's get started. So make sure you're on cyberskillslive.com and click on Defend the Rhino. So at the top of the page, you'll see the part that says it's today's live lesson. You want to click on the button that says Start the live lesson. Then what you're going to do is follow the instructions on screen and you're going to be answering the questions.
And once you've gone to the website and you've signed in, we're going to start tracking your progress and give you lots of hints and tips along the way. So don't worry if you fall behind or if you get stuck, or if you've never done anything like this before. We're going to make sure that you have everything you need to get through it. So once you sign in, select your school name from the drop-down list so that we know where you are. And I can already see, Craig, we've got a lot of Digital Park Rangers joining us so far. Thank you for joining and taking part. Again, don't worry if you've just joined. We're just getting started, so you've not missed anything yet.
Yeah, I can see Fergus from Duns Primary's joined us, Lexi from East Calder Primary as well, Archie from Duns Primary as well, and Jalfi from East Calder Primary School as well, and Emily from Duns Primary. That David, there is a lot of people joining this morning, so I would just say that if
Primary as well, I can see them joining.
Perfect. If I can see, if something goes slow for you at some point today, because there's lots of people playing, then I would just wait a minute and then just refresh the page that you're on. But the good news is, David, that we're tracking everyone's progress, so you're not going to lose anything. Is that right?
Exactly right. And if you're a teacher, remember that you can tweet us as well using the handle @data_schools. We love to see your pictures and your nice messages of support. So if you're a teacher, get your phone out and give us a tweet. And at the end of the workshop, we'll be giving you a short feedback form where we'll ask you to all tell us what you thought today. So please make sure to fill that out.
So we're already starting to collect some data about you. So I can see things like your park ranger name and I can see your avatar. So David, maybe we can bring up our data dashboard.
Yes.
So this is where we can analyze all the data that you're currently sending us. So we can see already, David, that we've got quite a few schools and groups coming through here.
Yeah, and we can see your avatars as well. As you sign in, we can see your name and your avatar. And it looks like we've been collecting a bit of data as people have been signing in, Craig.
That's right. So at the start, one of the first questions that we asked you is, what is your favourite wild animal? So we've collected that data by asking you that question. But now what we can do is start to analyse the results and try to understand the answer to the question, what animal is the most popular? So David, let's look at the data.
Oh, here we are. So this is one way that we can visualize some data that we've got. This is an example of a data visualization. So rather than me just reading out the numbers, we can put it on a chart so that it's easier for us to understand. So Craig, looking at this, I'm facing the wrong way. Looking at this chart,
here it is, David.
What does this tell? What does this tell you, Craig?
Well, I can see just by looking at it, there's a mix here as well. Like, although today's session is about Defend the Rhino, it seems like there's quite a few popular animals. Elephant looks quite popular. Giraffes are quite popular. I would say hippos at the moment are the least popular, and that's what I can get here just by looking at this graph.
And the red section, that's rhinos. And I'm surprised, Craig. I would have thought that would have been overwhelmingly the most popular animal, but it seems that they've got a bit of catching up to do.
Excellent. So yeah, that's what we're going to be doing throughout today. We're going to be collecting data, analysing it, and you're also going to be using it to help answer some questions and hopefully protect some of the rhinos.
Craig, I just found out that we're getting a transmission from Bokamozo the park ranger.
Oh, put him on.
30 minutes until the poachers attack. Keep going.
Oh no, we better get
started. Snap.
So the first thing you need to do is start collecting the data. Now, we've got security posts across the national park which have a bunch of sensors that are recording data. So what we need you to do is collect the data from those posts.
So follow the instructions on your screen and let's collect the security data.
So, David, we're talking about collecting data here from security posts. What are these sort of things? What sort of data are we collecting?
Yeah, these are posts that are dotted around the park and they have different kinds of sensors in them. So they collect lots of different kinds of data. They collect data about the weather, light levels. They have motion sensors, so they can detect movement as well. But the most important thing they have, Craig, is they have cameras mounted on them. So they're constantly taking pictures around the park. So what we need to do is collect these pictures and analyze them so that we can find the poachers. To do that, you need to download these photos from the security posts so we can start our analysis. So keep following the instructions and let's answer the questions and download the data from the security posts.
David, I can tell you that like these sensors, I know that they've got these posts have a lot of sensors in them. A lot of the schools who are taking part today are part of an Internet of Things project. So they might have been sent boxes which have different sensors that they are using to measure things. That's actually very similar to what's going on just now, isn't it?
Yeah, absolutely. It's very much the same sort of thing.
Except our sensors, I think some of the sensors that your schools might have been sent out might be things like temperature sensors or humidity sensors. That's not quite the same as what we are looking at as well. With these posts.
The photography is really the key part to these posts, I think, because it's a security system as well, Craig.
I'm just looking here at some of the answers as they're coming in. A lot of people going through the questions and answering them correctly.
And if you find while you're playing today that it's a little bit slow or it takes time for things to change, there's a lot of people playing. You can see we've got over 200 park rangers taking part. So just hold on and we'll get your answers eventually.
So I can see that Theo, you've been sending in your answers. Emily from Duns Primary School, you've sent your answer in as well. Layla and Esme from Cramond Primary School, thank you for answering this as well. David, I'm overwhelmed at the number of the progress people are making here as they work through this.
I know, it's impressive, isn't it? And I can see that a lot of people are still signing in as well. So if you're just getting started, don't worry, you haven't missed anything. You'll be able to catch up with us.
Okay. Let's give people another minute to do that, David, and I'll see if I can progress through the activity as well.
Good idea.
I'm still working through it.
Take your time, Craig.
Do you want to give a few shout outs, David, while we...
Yes, absolutely. I'm glad to give a shout out to everyone who's joining us from Fife and the Clean Primary School and St Margaret's Primary as well in Fife. Thank you for joining us today. And also Holly at the University of Edinburgh. It's great to have you with us today.
So people are really starting to look through these images just now, David, and I can see that people are downloading them as well from our server.
Exactly.
So what tool is it they're using to do that just now? I'm just typing in the commands just now to take part.
We're going to use a terminal to give the computer instructions to download all of these images. So the tool is called wget, and that downloads all these images from the server in a big zip file.
So what people are doing just now, David, is they're looking through these images here, right? So these are images that have been collected by the sensors across the park. So what is it they should be, looking for in these images? What are we asking people to do here?
Yeah, the crucial thing that we're looking for is to see if there's an image that has a human being in it. Because potentially, Craig, if we find a photo that has a person in it rather than like an animal or a shrub, that suggests that could be a poacher who's coming to attack the rhinos. So we have to look through all of these photos once we've downloaded them and see if we can find a poacher or at least a person in the photos. So we're looking for people basically.
But David, there's loads of photos here. Like I'm starting to go through them a bit now. There's thousands of them. In fact, I would say there's millions of them.
And how many in total would you guess there are, Craig? How many photos?
You tell me. Millions by the looks of it.
By my guess, I'd say at least like 16 million photos,
okay.
Which is a huge amount. So we have to work really quite industriously and look through all these pictures.
So I can see what people are doing at the moment, David, is they're working through looking at these images. So they've got a massive list of all the different photos, and what they're having to do is scroll through them and see if they can identify a poacher in those images.
Exactly.
But it's taken a long time. Like, there's a lot of photos here. I can see people slowly starting to work through them.
The server is creaking as people are doing this. But keep going. I can see that we're making a lot of really good progress so far. And we're looking through a lot of images very efficiently.
So what you're doing here is you're analysing the images to see if you can find any poachers. So the idea is that you're looking to see if you can find an image with a human being in it, because that might be a poacher who's about to try and attack the rhinos. And we have loads of images to get through, David. There's nearly 16 million of them.
How are you getting on with your activity, Craig? Are you looking through photos right now?
So I've still got mine up here, but I don't think I'm going to be able to get through it in time. I think we should go to the dashboard and let's give people a minute or so just
Good idea.
to catch up, because I can see that they're working through it.
A lot of good answers coming in here, Craig.
Yep, you do that while I get my
I can
images
see
sorted.
Elliot at Crammond has just downloaded their images. Well done. Lily M and Scott at East Calder. Maisie, Riley, Ceres, and Ryan at East Calder as well. Well done. And Alexander is downloading their images too.
And Yannick, you've spent some time looking through those images. Hayden as well, you've downloaded these images. And
so many images being
downloaded.
downloaded.
I know. Let me see if I can find some as well. I'm trying to help out here by going through them too, but I don't think we're going to be able to get them through in time, David.
Do you think so?
I think there's too many. Like, there is no way we could check 16 million images ourselves. It is so tiring.
We've only got half an hour to do it, Craig.
That's it. Should we show you my screen a second and I can show you what it's kind of looking like here? So
Why don't
you
talk us through, Craig, what you're looking at?
So these are all the images that are taken by the security posts here. So what we need to do is scroll down, and what you need to be doing is looking for any photos that you think that have got a poacher in them. Now, I can't see any with a poacher at the moment here. But there's 15.
There's a giraffe. I see a giraffe.
Yeah, but that's not a poacher, David. That's no use. Like, we need to scroll down. Right, so I've examined 80. I better keep going.
Yep.
No. David, this is not going to work out doing it this way. Doing this type of image processing where you would have to manually check all the images. Yeah. We've only got half an hour to do it. There's nearly 16 million here. Look, we need to find a better way to do this, David.
Yeah, and the other thing is, Craig, we've got more images being taken every second. Like, the cameras are constantly taking photos. I don't think, I agree with you, I think it's going to take far too long to look through all of these images. And actually, Craig, I don't want to alarm you, but I've just been getting a message through from Bokamozo.
Let's put them on.
15 minutes until the poachers attack. Hurry!
Oh, we don't have much time. So we need to stop the poachers before it's too late. I think we need to find a way to use technology to help us, Craig. Remember that computers are much faster than humans at doing certain tasks. So possibly we could teach a computer to look at all the images for us. If we could do that, maybe it could do all the hard work for us and we wouldn't have to search through millions of images. Yeah,
that's what we're going to do. You're going to teach the computer how to recognize pictures with humans in them. So to do that, what we need to do is we need to show the computer examples of photos that have humans in them. But we also need to show examples that don't have humans in them, so without humans in them. And what you're going to be doing here is you're training the computer. You're telling it what's in that photo, and it's learning from your decisions. So this is what's known as supervised machine learning, because basically you're training the computer, you're looking over it, and you're teaching it how to understand, is there a human in this photo? Is there not a human in it?
So what you need to do is you're going to follow the instructions on the screen, and you're going to teach a computer what a human looks like, so it can do all the hard work for us, and we can stop the poachers. Now, David, I can tell I think we've got over 400, over 500 people doing this right now. So we've got a lot of training that could be going on here.
Absolutely. There's a lot to do, but using the computer should make our work a lot easier. Because if it can process the images for us, we won't have to manually toil and click through 60 million images.
Let's have a look at the dashboard for a minute, David, as well.
Here we are.
People are already going through this here. So Orla from No Park Primary School, Andrew and Evan from East Calder Primary School as well. Isla, David, they're all appearing on my screen so quick, I can barely catch up.
David and Judy at St. Margaret's. Jessica at St. Margaret's Primary School.
Thank you for training your model.
Yes, we're lucky to have so much help today, Craig. Normally we're stuck doing this ourselves. It takes much longer, but we're making really good progress here.
Well done to everyone. I think we've had a lot of answers coming in from Duns Primary as well and East Calder Primary School. Lily, you've been able to know that you need to be training it with photos that have humans in them and without humans in them. Yeah, that's really important.
That's important
for this task that we're doing. David, while people start to work through this and train this, tell us a bit about this project that we're doing today.
I'd love to, Craig. So today's live lesson is part of a project called Data Education in Schools. And the Data Education in Schools project is part of the Edinburgh and South East Scotland City Region Deal Skills Programme and is funded by the Scottish Government. So you can use data science skills to work in lots of different areas, in healthcare, agriculture, finance, tourism, the public sector, the creative industries. Loads of different jobs use data science skills. So if you enjoy today's activity, you could potentially do this for a job. You could work using data to help people and animals and do interesting things using data. And data skills are applicable and useful across all areas of science. So maybe if you're working in physics or chemistry, biology, computing science, wherever you're working, having data skills will be really useful in all of these areas. And being able to understand data and using it to make good decisions is important in so many jobs across these sectors.
Yeah, there's lots of jobs in this area in Scotland, and according to Skills Development Scotland, there's over 3,000 people working as data scientists as well. So after the event today, make sure you go onto the Data Schools website, so dataschools.education, and see some of the other things that are on there as well.
That's a good idea.
Now, David, we've got a little dashboard at the bottom here. What's going on here?
Yeah, so right below us on our screen, you can see we've got 4 very important metrics. Let's talk about them one by one. The most important metric that we're going to be looking at today is right below me here. Here. The machine learning model accuracy. So this tells us how smart our model is as we're teaching the computer to recognize people or to recognize animals. That percentage will get better as we train the model and it gets smarter. So our goal, Craig, is to get that percentage as high as possible today. We want that to be 100% ideally, if we can. Do you want to talk about the other statistics that
we've also got the number of images that are currently being checked by people taking part. So that's how many you're actually sending just now. So I know what you're doing on your screen at the moment is you're sliding left and right pictures. You're telling the computer, you're training it, is it a human or is it not got a human in it as well? And as we do that, the model accuracy is becoming smarter and it's becoming more accurate, I should say, not smarter. But the idea, as David said, we want to get that figure as high as possible as well. And I can tell you that there's thousands of people who are categorizing all these images just now. If it's going a little bit slow for you while it's analyzing these things, just give it a minute and then just refresh your page and you'll be able to keep going. We are saving your progress on the screen here. We can see that the model accuracy is going up. Literally, you're checking thousands of images per second, which is really good. So thanks for taking part.
It's CPU intensive, though. We can admit that. And so yeah, we want to get that number as high as possible. So keep going and keep doing your great work.
So I can see that Georgina from Duns Primary, thank you very much. You've been training your model as well. Chloe has been training their model too. Finlay from No Park Primary, thank you for taking part.
And Olivia, and Fergus and Rose, Georgina, well done everyone who's currently training their models.
So this task that you're doing right now, this is something that genuinely you would do if you were working in data science. So we would call what we're doing here image classification. And this is genuinely a way that you can teach a computer to identify things. So where might have you seen this? Where might have you seen this before? So like, David, have you ever been shown an image of something when you're on the computer and you're told to do something like click on the traffic lights in this photo, or click on every bus that you can see in this photo?
Yeah, sometimes you're trying to get onto a website and it will give you like a quiz question like that, like, can you spot the fire hydrant? And it's like a grid. And yeah, you do see that quite a lot on the internet, Craig.
Yeah, it's used by companies all the time. Companies might use this to help train their own systems as well. So Google do this, for example. Have you ever been onto a Google website and it asks you to like pick photos of like, where's the bridge, where's the traffic light? And that's because they are using this technology to help train their self-driving cars.
And it's pretty clever, isn't it, Craig? Because spotting fire hydrants or bikes is really quite easy for us as humans, because we've grown up living in cities or in towns, and we could recognize these things easily. But a computer won't necessarily know how to identify something like that unless you teach it. So Google is kind of getting us to do the work of teaching their computers for them.
Unpaid work.
Yeah, unpaid labor. It's very clever of them.
So if you've been doing that work for free for Google, maybe you should be sending them an invoice. Maybe you should be asking for payment for that work that you've done. But we are using it today for a good cause, in the sense that hopefully this is going to help us spot these poachers quicker. Because if we train our machine learning algorithms, then it can spot the poachers for us. And David, I think we're at a point now where, listen, within about 5 minutes, we've managed to image classify 5,000 images. And that's
great.
Thanks to you and your help. David, I think we should see if we can test our models or move on to our next phase here.
I agree. We've got an accuracy score now of about 85%, which is really pretty good. And I think, yeah, absolutely. Let's test our models and see if they're up to scratch.
Let's do that then. So David, I know you're going to move people on to the point now where they're testing their models. So
yeah. So in a few seconds, we're going to move on to testing our models. What were you going to say, Craig?
I was just going to say, so now that you've trained your model, let's test your model and see if it works. So what you're going to do is you're going to follow the instructions on the screen to try and test out your model. So this means your this is a way of checking to see if our machine learning model is going to do the work for us. Is it going to be able to check the poachers for us quicker? And hopefully it will be quicker than it would have been when we were doing it manually. So let's give people a chance, David, to run that test.
I can see a lot of people are testing their models right now, which is great. A lot of graphs being plotted.
Mm-hmm. Great. Let's have a look, David, on my screen here. So I'm running the test on the model that I've been training here. So we've got 2 lines, right? So this line at the bottom here is the time in seconds.
Yep.
And then this is the number of images checked. So this is me compared to the machine learning model that I've just trained. So
you're the purple line at the bottom.
I'm the purple line. Right. So within 10 seconds, I was able to check about 10 images. So I was doing about an image a second, right? Whereas the machine learning model was able to check 157,000 images. So much, much quicker than me as well. And within 20 seconds, much quicker than me, like 15,000 times quicker than me.
But it's not that you're bad, Craig. It's just that no human being could do it that quickly, right? It's so much work.
Yeah, for humans, like it takes us a lot of time to do that, whereas a computer can do these things quicker. So it shows us there that training that model is going to allow us to check more of these images. And I can actually see your results as they're coming through as well. Keja from Duns Primary as well. Anya, you know, your model's 14 times more effective as well. Jalfi as well. So,
and looking at the stats that I've got, Craig's, I think one of these are 14,000 times faster than checking manually. So that's a massive improvement.
So what we can do now, David, is I'm going to suggest working together to do this. What we could do is we could combine our models to form a potentially stronger model that could be even more accurate. Okay, so this is called ensemble learning. What we're doing here is we're going to bring our models together and hopefully create a more accurate one.
But how do we know that the combined model is going to be more accurate than just the ones on their own?
Okay, so the way that this works is what we would do is we would ask the same question to lots of different models, and then we see what the majority of them answering. So let's say we had 200 of your models today, right? And we give them all the same photo to analyze. And 190 of those models say that there is probably a human in that photo. Then I think that we can be quite confident. Like we've asked a lot of them, you know, together we're sort of more confident in our answer.
Okay, so to combine your models, you're going to need to upload them to us first. So keep going, keep following the instructions and upload your models to our server so that we can analyze, so that we can combine them together.
Yeah. So I can see, David, that there's quite a few people who are uploading their models to us just now.
Yeah, I can see people are working through that. And Lexi at East Calder Primary has just uploaded their machine learning model. Thea has uploaded their machine learning model as well. I can't speak today. And
Emmy as well.
Emmy. Mm-hmm. Nice work.
Where are they from, David, as well? Give us.
I cannot see where Emmy's from. Where's where they're from?
So I can see Kieran from Dunscore School is taking part as well. And Molly and Sophia from St Margaret's, thank you. You've tested your model and you've generated a graph of its effectiveness. Thank you for doing that. Mac from No Park Primary School, you're working through this as well. I can actually see there's a few people who have just joined. So if you've just joined, if you're one of the 100 people who have just joined in the past couple of minutes as well, then thank you for taking part. Don't worry, we're going to keep you up to speed here as well. Inez from East Calder Primary School, thank you for uploading your model.
And Rudy from No Park Primary, thank you. We've got your model there.
We're getting a lot of these together, David. I think we should get to the point where we can start using some of these together.
I agree with you. I think maybe just a few more to come and then we'll be ready to combine them.
Great. Looks like they're all starting to come through now. This is brilliant. Let's give you all another minute or so so that you've got time to upload them to us. How does that sound, David?
That sounds good. Yeah, the upload speed in the national park is a little bit slow because of our 3G is not very good. But I can see that we're getting all your models coming through eventually. So you might have to wait a little bit, but we are getting your models through.
Yeah, I think another 30 seconds or so should do it. Thank you, Maisie. Got your model in. Thank you very much. Ronan from No Park Primary, thank you for uploading your model. And Bailey Louise, I think we're ready to combine some of these models, David.
Yeah, absolutely. So shall I run the command on my little terminal here?
Yeah, let's combine these models.
All right.
Wow, David, that is a lot of models. We need to
It's
combine.
fantastic. You can see all your avatars coming together there. Do you see all your individual models coming through? That's excellent.
Brilliant.
So now that we've combined our models, I think we can use this new powerful model that we've created to check all the photos for us. So remember, Craig, we have over 16 million photographs to check. And when we were going through it, it was taking us like 10 seconds to get through, 10 photos. I think we said that if we did it manually, it would take us about 2 years to get through all the photos. So let's see
we don't
how
have 2 years, David. We
No,
don't have 2 years.
we don't have the time. Let's see how quickly the computer can do it. I'm going to run the command now to.
Okay, so you run the
check these
command
photos.
and let's run our model against those 16 million images. Let's see if it's any quicker.
Let's see.
Oh my goodness, David, that is so much quicker.
Look at them all going past. It's like a million going past in like 3 seconds.
This is brilliant. Look how fast it's able to change these images. Brilliant.
That's really cool.
I can see things are getting so much quicker. And this is much quicker than having to slowly go through it manually, isn't it?
Well, 2 years of work done in like 2 minutes is pretty good.
We did it, David. They're all checked. Well, you did it. You did
Fantastic.
it. This is
Well
so
done, everyone.
much quicker. Because you trained your models, we were easily able to check all those photos for poachers. So now we've got here is a list of the predictions from those models where the poachers might have been seen.
Craig, I don't want to alarm you, but there's another message coming in from Bokamozo, and he sounds pretty worried.
You should put them on. Put them on.
5 minutes until the poachers attack. Quick, tell me where to send the chopper.
Okay, we're nearly there, but we need to be quick.
Follow the instructions and let's prepare this data for visualization, because what we need to do is figure out which group of rhinos is under attack. We've got these images, but we need to figure out who we need to defend, basically.
Well,
and also, Craig, time is not on our side.
No, we've only got a couple of minutes. So what you've got now is the results of us checking those images. We've got the locations where we think that there might have been a human. So you're going to have to visualize that data, right? And David, if you were trying to visualize data that is about locations, how might you do that? What might be a good way? Would it be a graph? Would it be a chart?
Well, a map might be quite handy for that, because then we can see exactly whereabouts the data points are. So I think that's what we're going to do.
That's what you're going to be doing. So you're going to take that data and you're going to visualize it as a layer on a map. So this is another example of data visualization, but your job is to help tell us what group of rhinos do you think are under attack from the poachers. We've only got a couple of minutes.
Let's work quickly.
I can see you're all working through it really quickly now. Lewis from No Park, Josh from East Calder, thank you. Jay from No Park as well. Bonnie from Duns Primary School, thank you very much.
Great work, everyone. I can
went
see
St.
Freya
Margaret's
and Karis as well.
I just wanted to give a wee shout out, David, there to St Margaret's Primary as well, because I don't think there is as many people taking part from there, but they're making just a valuable contribution too.
Excellent, well done, St Margaret's.
Okay, keep going. Let's see if we can find out where these rhinos that are under attack are. Which group? Okay, so a few people, I'm looking at the results here, David. A few people have started to identify where they think the poachers might be, which group of rhinos, but not enough for us to be sure yet. Let's give it another minute or two.
Keep going.
Scott thinks he's identified the poachers on the map. Thank you, Scott from Duns Primary. Keep going, everyone.
And
Jay
John
from
at
East...
Duns Primary as well. I think he's got a guess for us.
Okay. Maya from No Park Primary School, you think you've identified them as well. Thank you very much. I'm going to have to look at these. I'm going to look at the results here, David, but let's get everyone another minute or so to
Good
work
idea.
through this. Oh, David, they're all coming through now.
Stirling at the University of Edinburgh, well done. You've identified the poachers on the map. Keep sending those answers in.
Finlay as well from No Park Primary. Kieran from Dunscore School. This is brilliant. David, I'm going to have to look at these, right? Okay. Right. The same answer is coming through all the time, David.
Mhm.
I think we might have it. Okay,
What is
so I think we know that the name of the group of rhinos under attack, based on the data that's been sent to me here, we think it's Umatatu. Umatatu is the name
Umatatu?
of the rhinos. Yep, can you let Bokamozo know?
Are you certain about that, Craig?
Well, based on all the information that's getting sent to me,
I don't want to send a helicopter to the wrong group of rhinos. Umatatu.
Listen, Umatatu.
Okay, I'm going to let Bokamozo know. Let's see what he says.
Oh,
You did it! I've sent the helicopter. The park rangers are on their way.
well done. You did it. We found out that the group of rhinos that are in danger is Umatatu, and we have sent out a helicopter to deal with the poachers. Well done, everyone. Thank you.
Excellent work. And you've had to do a lot of work today to defend the rhinos. First of all, you downloaded a data set of 16 million images. And to do that, you used a terminal to give the computer commands. And then you experimented with processing this data by hand. You looked through all those photographs manually, looking to find a poacher. But we figured out that would take far too long. It would take 2 years to do it manually. So instead, you trained a machine learning model to find humans in photographs, and you ran that model against the data set of 16 million images. And finally, you created a data visualization to understand this data. You used a map to show where the poachers are in the park, and then we were able to send out a helicopter to deal with them. Well done.
Well done. Thank you for being part of our data science team. We couldn't have done it without your help. Your hard work in training the model and using your data science skills has kept the rhinos safe for another day. Now, there is one last task that we really need you to do, and it's important. We need you to answer some questions about today's event and tell us what you thought. So make sure you click on that button now. There's a button, David, isn't there?
Yes, there's
It
a
says-
feedback button, a big red button. Once you get to the report card, press continue, and there's another page that will ask you to press a big red button to give us your feedback.
So we're on YouTube. If you're a teacher and you're taking part today, you will get your own feedback form in your email inbox right now. It's just a short couple of questions, but again, that would be really helpful for you to fill that out today, straight after the lesson.
Very, very helpful.
Now, we're on YouTube today, David, so of course, make sure that you like the video, that you subscribe to the channel so that you can see other lessons like this in the future.
And yeah, exactly. If you're a teacher as well, remember you can tweet us a photo of your report card to us using the handle @data_schools. Here are the details here. Also use the hashtag #DataSkillsLive so we can see your lovely photos. Craig, I can see the No Park Primary 6 and 7 have been tweeting and have sent us a great photo over Twitter as well. So thank you for sending that in, No Park Primary. We've had so much fun defending the rhinos with you today. If you've enjoyed the activity, why don't you try out some of our other data science activities? We've got Code Your Own Data Selfie and Plug in the Numbers. You can see all of our activities, which are free, on our website, cyberskillslive.com, and they'll keep you busy all day.
I can see a lot of you have already started sending in your feedback. Thank you very much for that. But make sure you take a couple of minutes to do that now as well. Thank you for joining us today. And I think, David, that's the rhinos safe for another day.
Yeah, they can rest peacefully for once, which is good.
And thank you for everyone who's taken part as well. So thank you for joining us today. And it is goodbye from Bokamozo, and it's goodbye from David.
Bye.
And it's goodbye from me as well. Bye-bye.
Apex dropping bombs.